Sorry about that, folks. Getting used to the volume there. Thanks for stopping by here at the Landhammer Stream. We're going to talk some today about bandwidth delay product and also, the lab muscles. And I'm sure you know what I'm talking about when I get to that. And a couple other things related to the CCIE track, of course. I'm preparing for the written. I'm doing some lessons today. And just kind of want to talk about my pace and things like that. And also get a little cloud in. Might talk a little cloud. So we'll keep it brief, though, tonight, folks. I know everyone. Hope you're having a great Tuesday night. Getting ready for, whatever your study plan is this week, whether that is hitting the books, doing labs, collaborating with someone, or if you're working, whatever the case may be. Wish you the best. This, of course, I think this is the same as yesterday. This is a Galaxy. Actually, no, it's not. This is different. It's called the Green, I forget. Gexzilla? The Green Pea. Actually, that's the one I intended to show, but I think this is from yesterday. But anyway, let's talk a little bit about, actually, before I kick off exercising lab muscles, let's talk about Azure CLI versus PowerShell. There's the discussion about this on Twitter. As many of you may or may not know, I've been getting involved. Hey, in my forces. Thanks for checking in, my friend. Thanks for hanging out with us here in the chat. Doing well, man. Everything's going well. Yeah, everything's going good. 69 days till the next exam is scheduled, so getting ready for that. But yeah, typically in Azure, like really with the other cloud providers too, of course you don't want to have to log into some web portal every time to do work in those environments. You want to be able to use a CLI, right? Just like you would whenever you need to script anything. And of course, with the cloud providers, you can do that pretty easily. They have tools that you can download to your computer, and essentially you connect your CLI session. You're credentialed to your cloud account and the cloud provider. You do all sorts of things, right? Like I have this, I don't have it set up. I'm not logged in right now, but I can do AZ, and the Azure Cloud or Azure CLI is running, and there's a whole host of different things you can do in here. There's a lot of commands, and there's a lot of options for a lot of those commands. So with Azure, though, it's typically either Azure CLI, which is very Linux-like. In fact, you can, when you log in to your Azure portal, you can select like a bash shell. So they have, times have really changed, because I remember when, is essentially an all-out war between operating systems, between, Microsoft operating systems and, of course, Novell operating systems on the network side, on the server side, I should say, and then, of course, Linux and Unix. And Solaris was in the mix for a long time. But now we see that's pretty much consolidated, and also Windows has realized that, a lot of people want the Linux functionality. Like in Windows 10, you can get a bash shell, sort of a Linux subsystem, which I don't have because in my work PC I'm running Windows 7. But I hope to get that soon. But yeah, with Azure, it's, they're very open with you using Linux-like shell, the bash shell, and that's kind of like what Azure CLI is. Of course, it is for native Azure objects, right? Whether that be your subscription, resource groups, things like that. So we'll see. I will comment a little more on that. I want to get some more feedback on Twitter, just see what people are doing. I thought about doing a poll, but opted not to do that. And I'll do some videos later as well, because I do have a subscription right now. Azure has a deal. They have a $200 free, and I think it's 2 months for $200, and $200 to spend to do as you will in Azure and play around. Just like Google Cloud has $300, and AWS also has an account you can set up for free, but they give you limited access. Like there's certain things you can spin up, but it's a little different, right? So I plan on doing some videos on that stuff. This is CCIE focused, channel, but as I'm dipping more into doing cloud things, cloud engineering, cloud architecting, and things like that, I'm involved a lot more with that now on my job. So I plan to share some of those things that I can And some of that content will be coming out, everywhere like I have now. It'll be on Twitter, on Instagram, and some YouTube videos. I won't do as many things like that, labs like that, yet, here on this Twitch channel, because this is pretty much dedicated to CCIE. But I don't know. We'll see. If people want to know more about that stuff, they want to see more demos of that, if they're labbing that kind of stuff too, we'll do it. There was I'll talk about that a little bit in meat chunks. Exercising lab muscles. So this is a thought I had watching Show IP Interface Brief's vlog. I think it was last night. It's the one he posted last night. I could be wrong. But he was talking about how he had been away for, just a few days. And then he went back to another lab, and then he missed some basic things. And he was talking about, the lab muscles. And I feel a lot of that too. Like in the last few days, I've done a few little labs in Eve, but it made me think about, I've sort of accepted that for right now, that I'm not going to be doing a lot of labbing, and I'm really focused on the written material and the content and the written blueprint. And I know that when I do get back into labbing, once I pass that written exam, when I do get back to labbing, those muscles are going to be, and it's a good analogy, because when you don't use muscles for a while, and then let's say like in CrossFit, for example, I do CrossFit every day. This morning I did front squats, and we did some ring push-ups. And anytime you do something in CrossFit that you haven't done a while, they try to be very, varied in the programming, but once in a while something will pop up that you have not done in a while, and it might hit a muscle group that you have not used in a while. And what's going to happen is it's going to be awkward at first, and those muscles are going to hurt. And it's kind of the same way I see as really anything we do with our mind as well, including labbing. So I really get that, and I appreciate seeing that in his video. Everybody definitely, check out Tony's videos. He's putting out some good quality stuff. So what I've been doing lately on the written is, just to give you, kind of breakdown, I've been doing some review, of course, of notes from the written fail, as well as going over networklessons.com. And I feel like that's going to help me identify, not even identify, but review and dig deeper into some of the gaps I have. And some things like this, bandwidth delay product, like I know about it. I know in general what the formula is, but I haven't really sat down and pondered it enough, like spent a little time with it. So I wanted to do a little bit of that today, and I'm going to do some of that on stream. And essentially what this comes down to is when you're studying about TCP and, the network controls and calculations, and essentially trying to get as much bandwidth as you can, utilize as much bandwidth as you can with TCP. Because TCP, of course, UDP is just going to throw packets out, right? It's not going to try to figure out on this, path, how much data can I really send. It doesn't have that functionality, whereas TCP does, at least UDP on its own. There's some things that may sit on top of UDP, or applications that sit behind UDP that do some of that. But TCP, that's one of the big advantages of TCP. And one of the important things about TCP is the window size. In TCP, of course, when a connection is formed, one thing in the acknowledgments is that comes back on the data packets. It's an acknowledged. So the acknowledgments that come back define kind of on the other end the receive window size. So I'm going to try as a sender to maximize my throughput, realizing that from time to time I may, depending on the path and the latency along the way, in both directions, as well as the buffering ability on the other end, that window size it scales, right? So it is a sliding window, and depending on, if you have, for example, on one end of a LAN, if you have a device with a gigabit link and you're trying to send a large video file, for example, or copy a large file to another device on the other end that has 100 megabits per second, or maybe it even has gigabit link on the other side, but it has a very small amount of RAM, and it has a very slow processor. So that's going to affect the buffering of the data. Once data hits that link and is inbound, then the protocol stack has to process it, and it has a buffer window, but maybe you don't have a lot of RAM, or maybe due to the slow processor, it takes a while to process that data that's in the buffer. So depending on that you're going to get feedback. The sender is going to receive feedback over TCP of, this is my window right now, and it may drop down to 0, which is not good. So what will happen is if we get a window of 0 as a sender, then we're gonna wait a while until and then attempt again to send more data, right? And one thing that's important as part of that formula in calculating, kind of what is the window size. We can talk about window sizes too for a minute. So there is a default on certain operating systems, and I don't know those off the top of my head, but I want to look those up because I believe like Windows depends on the version. Let's take Windows 7 TCP window size. How to adjust. Yeah, so here's, there's some good articles on this. What is yeah, let's see Microsoft. So there's send window and receive window, buffer size, latency net. Yeah, in all recent Microsoft Windows implementations, window scaling is enabled by default. You'll find places on the internet telling you to change registry values to increase your window size, and I've heard that. And here we go. Okay, so it's interesting. This Microsoft actually refers to an ovic.com. I don't know what this is. So there's some maybe some good explanation here. And it doesn't really tell us. I used to know this information. Okay, please note we've been testing it and have seen that bandwidth is possible when using TCP. Yeah, TCP can be a complicated. TCP can be very complicated. There are a lot of algorithms in place, right? In play. Intel values are fixed, but there's also a feature in TCP stack of Windows 7 called TCP receive window auto tuning. Okay, I did not know about that. TCP receive window. Okay, this is the article I think that I've seen before. And interesting, they're referencing here BDP. Wow, there's actually a good article here. For the TCP stack and Windows XP, in case any of you have Windows XP and or Windows Server 2003 around, which I hope you don't because it's so insecure. The maximum retrieve window size has a number of significant attributes. First, the default value is based on the link speed of the sending interface. Okay. The actual value automatically adjusts to even increments of the MSS negotiated during TCP connection establishment. And on XP, you can set it to maximum as 65535 without window scaling, or this large number with window scaling. Okay. So there is some tuning you can do there in Windows XP. And I think, let's see, let's look at Windows 10. Actually, Windows Server 2008. Okay, interesting. So here we have a table. Someone's been investigating performance problems on Windows 2K R2 system, found they're due to TCP window scaling not always being enabled when a Windows 7 client connects to a Windows 2K R2 2K8 R2 server. Server behavior has been observed between two Windows 2008 R2 servers. Below the description of a test can be used to reproduce a problem. Now, this is what I'm talking about. This is what I've seen. Server response 8192 with a Windows scale shift count of 8. Okay. Initially, the calculated window size was 66048. This varied throughout the copy, reaching values in excess of 13 million. When scaling is not enabled, it takes 3 times longer to copy the same file. This is a major performance problem. By default, TCP window auto-tune feature is enabled for all Windows connections. Okay. And you can run this net show interface TCP show global on your servers and clients. Check if Windows auto-tuning level set to normal and post results. Okay. Yeah, so it's just something you want to be aware of, because I have seen in production, I have seen issues with this window size. And we have, there's actually different tools you can use on your network to, like if you have network taps, they will monitor the TCP performance. Like we have that in place in the data center. We have some of the key trunk ports are tapped, and the TCP data is monitored. Like it's in aggregate sent to an application, and the application is constantly monitoring the TCP window size. And we have seen issues where certain servers, for one reason or another, are really limiting their TCP receive window size. And again, this is something that you can configure, you can set on the operating system, on the server, but unless you're actually monitoring it on the network, where you have a tool that is monitoring the TCP window size. And of course, you can always do sampling. Like you can use iPerf, you can use some other tools like that. You can do wireshark and just send some large, start some TCP connections, try to send a large amount of data to that host, and just watch. And wireshark actually has some diagnostic tools built in as well that will show you TCP statistics. So it's really important as, a network administrator, engineer slash, architect, to want to be aware of window sizing in TCP, to be aware of the behaviors, and it's important also to understand this formula, the bandwidth delay product, right? So, and the difference between pings, RTT, latency, and delay. So pings, when you issue a ping, you get a number here, right? In milliseconds. So that's ping 1.1.1.1. So here's our milliseconds in our ping. And again, ping, of course, is just a tool, but you'll hear people say, my ping time is this. Well, what does that really mean? Well, ping time is just round trip time. So as you can see here, round trip minimum. Ping will tell you when you end it, or if you're doing it on a Windows machine, for example, it will default to 4 pings and give you these statistics. So this is your round trip. In other words, this is how long it took for the packet to get there and come back. And you have your minimum, average, max, and your standard deviation, right? Statistical standard deviation, which is cool. I've never actually noticed that. But a lot of people will look at this number, and you see the average is 31. So that's your ping time, which is really your round trip time, which is different from latency. So latency can be, I sort of equate it to delay, right? Latency is how long it takes for data to get from one host to another, but it's a time that can be, it's different from round trip time, because round trip time is always there and back. So latency could be, you could be measuring latency one way. So let's say our round trip times are slow. that means we want to know the latency, or as I would say, the delay, from point A to point B, and what is the latency and or delay from point B to point A, because it could be different, right? That's getting a little deeper. So there are tools to measure that as well, but that's, I want to make the distinction here. And when we talk about bandwidth delay product, we are talking about, although we say delay, we are doing a round trip time calculation. So bandwidth delay product is in bits, is the bandwidth in bits per second times the round trip time in seconds. And we see if we have a common factor here, which is seconds, right? So let's first, the example I had in one of my lessons, in network lessons, was what's called LFN, or long fat networks. And I'd forgotten all about that being a thing. But essentially that's like a satellite signal. So satellite signal, you can send, you have a very large, you can send a lot of data at once, but there's a very long delay, aka round trip time. That's just the nature of, you know, satellite communications, right? So they just call those long and fat. So it's fat because you can send a lot of data. There's a lot of quote unquote bandwidth, you know, width. So they're fat. So there's a lot of bandwidth, but there's a very long delay. And this is kind of an extreme example, but let's say you have this number here, and I'm going to use commas. So 5 million bits per second, right? Or 5 megabits per second times 500 milliseconds. That's kind of a long delay, isn't it? When you think about it. I mean, this is 31 milliseconds. So 31 millionths of a second. It's pretty darn, just think about that for a second. Literally. You know, that is pretty darn fast, right? Which is what we expect. But when you think 500 milliseconds, so that's half a second. It's exponentially longer than what we're seeing here across the internet using my broadband connection. So basically what we can calculate for bits, and again, this is trying to calculate sort of a window size. This is pertinent to the window size that we should be expecting, right? So here we have, let me put some zeros here because I cannot just look at this number and tell you what it is. So that is 2,500,000,000 bits. And if you want to convert that to bytes, which we do, you divide that by 8. And you have 312 megabytes. Okay. So that is our essentially bandwidth delay product. Now to compare that, let's just take, I just want to take a broadband connection here, right? Just my broadband connection should theoretically be 30 megabits per second down. And I should use the up, huh? I think it's 5 up. So we'll do 5. So that would be 5,000 bits per second times. Let's say the delay here, the observed delay, aka round, well, see, I know I'm saying delay. It's really round trip time, right? Is, we'll just round it up to 30 milliseconds. So how many is that? So 5,000 times, I could have done that in my head. 150,000 bits. So that would be 150 megabit, or no, sorry, divide that by 8. Let's see, 150, 123 divided by 8. 18,750 bytes. So it helps give us a comparison, right? So we can see that this, let me make sure I did this right. So 5 megabits per second. That would be kilobits. Yeah, it's the same. Yeah, what am I doing? 5,000 bits per second. That's 5 kilobits. So we're actually the same as the satellite, aren't we? So this should be a lot better. 123 times 30. Yeah. 150, comma 123. Times 30 milliseconds. 150, okay. Divided by 8. Yeah, we're just adding. Okay. Wait, did I do that right? 150, because this is actually a smaller number. Divided by 8. Yeah, I'm not sure if I did the one above right. Let's see, 2, all right. 2500 123 123 divided by 8. Okay. Five 123 times 500. Correct. Divided by 8. 312 500. Okay, so let's see. Broadband is 5 123 times 30. Yes, divided by 8. 18000 18750 bytes. Okay, so looking at this, this is interesting. So I'm not sure I'm understanding this correctly, because as we can see here, this number is oh, I know what I'm doing wrong. Okay. So this is bits per second, or no, round trip time in seconds. Okay. So this is actually going to be 0.5. 0.5 seconds. And that's half a second, right? So this is going to be 0.003 seconds. 3 milliseconds. 500 milliseconds. Right. Okay. That's where I went wrong. 5 123 times 0.5. Okay, that's more like what I saw in the lesson. Divided by 8 equals 312 500. Okay. Now we're making sense. All right, now let's go down here. 5 123 times 0.003. 15,000. And divided by 8, 1,875 bytes. Okay, so I'm not sure I have this figured out, because your bandwidth delay product, what is this number? Is it just for comparison? I thought this was in relation to window size. So what I'm going to do is, over on another screen here, I'm going to pick up I'm going to open this network lessons. And if anyone has any insight, definitely give a shout out. All right, we're going to go to the course, networking principles, network theory, TCP operations, bandwidth delay product. Okay. The window size is typically configured in bytes, so this would be 312,500. Right, so this is what our window size would be for this connection. Okay, let's see. Wow, he has a like an iPerf demonstration in here. I may want to do this on stream. Okay, so the other example here is, this is my broadband. Let's go with a gigabit link. So we're going to say a gigabit. So that's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, that's 1,000, a million. That's 1 gigabit times 0.001. Let's say there's 1 gigabit link with 1 milliseconds round trip time. So what is that going to be? That is going to be 1, 1, 2, 3, 1, 2, 3, 1, 2, 3 times 0.001. 1, 1, 2, 3, 1, 2, 3. So that's going to be 1,000,000 bits. And divided by 8. One, 2, 5, 0, bytes. So that would be our window size, which is still smaller than the long fat network. So I guess this is relative. For example, we obviously get a lot better throughput on this link, this gigabit link, 125,000 bytes. But the TCP receive window is smaller. And I'm assuming that's the case because it looks like, since we're going to be sending with a greater frequency, it would have to be smaller. It looks like this is very dependent upon the round trip time, right? The reason for the long fat network to have a large window size is because there's such a long delay from receiving an acknowledgement back that we want to send in bigger chunks. Okay, and obviously as we have greater throughput and a very low latency, we want to send in smaller chunks of data. And on this one, so it's not, I was trying to correlate these figures, and it doesn't look like they correlate necessarily to each other. This is sort of an algorithm that TCP works best with. So I think that's a conclusion I'm going to reach. I have not finished the lesson. So I'm going to do that. I was kind of reviewing this before the start of the stream. So I'm going to review that. I might do a little iPerf. Let's see, iPerf for the Mac. Is that just... It's been a while since I've used iPerf. Okay, so we got binaries. Oh, there's public iPerf servers. I haven't used this in a while. I need to play with this some more. Yeah, iPerf is a great tool because, you know, you can install it. I love when you install it on different ends. Like we could test this with a cloud. I've got a server running in Azure Cloud right now, in Azure. And I think it's the South Central region. I would love to do a test. That would be a cool video, is to do a test of, you know, round trip times between different Azure or Google Cloud for that matter. Google Cloud, I think, is in South Carolina. It was the closest data center. You tend in clouds to try to, you know, fill out your traffic and introduce the least amount of round trip time geographically. So you try to get geographically close regions. The problem in the cloud, though, is that in Azure, for example, not all regions are created equal. Like some regions have features that others do not. Also in Azure, you have disaster recovery pairings. So you have certain data centers that are naturally set up to pair with other data centers when it comes to some of the, you know, high availability or disaster recovery features. So you have to keep that in mind when you're designing out some of your solutions. But anyway, I digress. Yeah, I may do this, folks. I may download iPerf for the Mac. Looks like there's binaries, so it shouldn't be too big of a deal. Android, Mac OS 10, yeah. Download iPerf binaries. And there we go. .13. Cool. Oh, okay. Wow. It just runs. So I can put that as an app. Install that there. Let's just fire it up. iPerf 3. First time I think I have to right click. Midstream malform file. Oh, that's fine. Oh, it wants to run in a terminal. Interesting. All right. Let's see how this works here. User docs. Oh, I bet I have to run this. Oh, that's right. CD. Yeah, I'm not sure how to run this. All right, I'll figure it out. Oh, you run as Damon. That's cool. So yeah, I'll probably play with this some, folks, and maybe we'll stream about this a little bit tomorrow because I want to make sure that the statements I made tonight, that my understanding is correct. So that it's not important. It doesn't sound like it's important to compare one number to the other. The main thing is you want to develop a good, you know, receive window that is calculated based on, you know, the type of connection that you have, you know, the throughput, their bandwidth, and the round trip time on the connection. So yeah, I think I'm going to revisit this tomorrow a little bit. I'm going to play with it some more tonight. Probably play with iPerf and just see if I can get that working and do a couple demonstrations, see what I'm getting on my connection, and then compare it to some other connections that I have access to. That's it, folks, that we're working on. We're just grinding on our lessons, going through the networklessons.com, which, as you see, it's very helpful. And again, these are things that I'm trying not to just know the formula, but understand it. And that's where some of my weaknesses were before in the written exam. I think why I failed is I would see something, I would kind of know that, you know, I know what the formula is, BDP is BPS times RTT. Well, what does that really mean? What is it used for? And how is it, what are some sample calculations? How do they compare to each other? What does the number mean, right? So that's what I think is really important in this thing, making the difference for this next attempt. Stream update, I just want to thank the subs because the notifications aren't working right. Banner MOTD subbed again a couple days ago, so I'm a little late on that, but thank you so much for the sub. Appreciate it. Couple of meat chunks, GNS3 in Google Cloud. So we know that Tony E in the Discord recently did a video on how to do even G in Google Cloud. Well, someone has done I think it's a blog and a video on how to do GNS3 in Google Cloud. So I'd be interested to see. I don't know. There's so many ideas I have about cloud, right? I think it's what I'm doing now at work. We're moving workloads into the cloud, and I just see it becoming more and more popular and more options. And eventually, it's not going to be so important to have. I mean, there are a number of advantages. There are advantages to local hardware too. I won't go over all that now, but I just think this up and coming thing. I'm real curious. I have a lot of ideas of things that I would like to test myself in cloud and do videos on, but we'll see how much time I have for that, right? Also, there's an OBS update. Someone did a video. This is a great. I think it's Gaming Careers is the name of the YouTube channel. Great content on streaming and stuff. But I need to. I haven't watched this yet, but I know it's going to be good. I know that there'll be some great features I've already read about in the latest OBS. I think it's 22. And I haven't installed it yet, but I'll be installing it soon after I do a backup and testing out some of those new features. And then customize your wireshark columns. Who doesn't need that, right? That's good stuff. So anyway, I thought I'd share those links. Thanks so much for stopping by, folks. Appreciate the shout out in the chat. And folks, hope you have a great rest of your night. The week is still young. Plenty of time to catch up if you need to, or continue on your grind to get that cert. So keep it up, folks. Thanks for stopping in, sending you good bits, and we'll see you back here tomorrow night in the LAN Tamer stream. Have a good night.